What if the biggest building ever constructed on Earth wasn't a skyscraper? Or a stadium? Or even a government complex? But a single chip factory? Elon Musk just committed Tesla and SpaceX to a project so large that, if completed at the scale currently planned, it would become the largest building by floor area in human history. 100 million square feet. A price tag that has already reached $16.8 billion for Phase 1, with filings showing a possible total of $119 billion across all phases. And the reason, according to Musk, is brutally simple. We either build the Terafab, or we don't have the chips. This is not a normal factory announcement. This is Tesla and SpaceX saying the entire global semiconductor industry cannot supply what they believe they will need. So the real question is not whether the building is big. The question is whether this $119 billion bet is necessary. Or whether expectations are once again running far ahead of reality. Stay with us. On March 21, 2026, Elon Musk formally launched Terafab. It is a joint semiconductor project between Tesla and SpaceX, with Intel later joining as a manufacturing partner. The goal, according to company statements, is to produce more than 1 terawatt of artificial intelligence compute capacity per year. For context, the entire United States currently generates roughly half a terawatt of electricity in total. Musk has repeatedly said that existing global chip production covers only a tiny fraction of the volume Tesla and SpaceX expect to need for Optimus robots, robot axis, and space-based data centers. In August 2026, Tesla and SpaceX confirmed the full-scale site, Grimes County, Texas, northwest of Houston, on the former Gibbons Creek power plant land. They also locked in a first-phase investment of $16.8 billion. Earlier SpaceX filings with Grimes County had shown a possible total investment of up to $119 billion if all phases are built. The finished complex is planned to cover up to 100 million square feet of manufacturing space. That would make it significantly larger than any existing building on Earth by floor area. Musk called it the largest and most valuable building on Earth by far. The announcement shocked the industry not only because of the size, but because two of the most aggressive technology companies on the planet were essentially declaring that the current chip supply chain is inadequate for their future. Why now? Because Tesla and SpaceX believe they are about to hit a hard wall. Tesla needs enormous volumes of specialized AI inference chips for full self-driving, cybercab robot axis, and especially Optimus humanoid robots. SpaceX needs high-power chips designed to survive the harsh environment of space for its planned orbital data centers. Musk has stated that current global fabrication capacity is only about 2% of what the combined companies will eventually require. If that assessment is even directionally correct, the implications are massive. Investors care because chips have become the single biggest potential bottleneck for Tesla's AI and robotics ambitions. Competitors care because a successful vertically integrated fab at this scale could give Tesla and SpaceX a structural cost and supply advantage. Consumers and workers care because the project is projected to create at least 3,000 jobs in rural Texas and could reshape the U.S. semiconductor landscape. The stakes could not be higher. If Terafab works, it becomes one of the most important manufacturing projects of the decade. If it fails to deliver on time or on cost, it becomes one of the most expensive lessons in industrial overreach. Let's separate confirmed facts from company claims. Confirmed. Project announced March 21, 2026. Full-scale site confirmed in Grimes County, Texas, August 2026. First phase capital commitment, $16.8 billion jointly by Tesla and SpaceX. Earlier SpaceX tax filings referenced a potential total of $119 billion across phases. Prototype research fab already under construction at Giga Texas in Austin, ground broken April 2026. Intel is participating and its 14A process has been publicly linked to the project. Planned floor area, up to 100 million square feet. Expected jobs, at least 3,000. Company claims and goals. Produce more than 1 terawatt of AI compute per year. Long-term target of up to 1 million wafer starts per month. 100 to 200 billion custom AI and memory chips annually at full scale. Fully vertical integration of logic, memory, advanced packaging, and testing under one roof. These are extremely ambitious numbers. Independent analysts have noted that reaching a full terawatt of annual compute capacity would require capital expenditure far beyond even the $119 billion figure in some estimates. No chips have been produced yet at scale. No volume manufacturing timeline has been locked in with hard public dates. The evidence shows a serious commitment of capital and land. It does not yet show operational success. Terafab is designed as a vertically integrated semiconductor complex. That means design, fabrication of logic chips, memory production, advanced packaging, and testing would all happen in the same facility. Traditional chip supply chains spread these steps across multiple companies and continents. Tesla and SpaceX want to collapse that timeline. The prototype facility at Giga Texas is intended to allow rapid iteration, make a chip, test it, revise the mask, and repeat without shipping wafers between distant sites. According to Musk, Tesla is leading the research fab while SpaceX leads the initial large-scale build. Intel's involvement is significant. The company has struggled to regain leadership in advanced manufacturing. Partnering on a high-profile project like Terafab gives Intel a major potential customer for its next-generation process technology. The chips themselves fall into two broad categories. Edge inference processors optimized for vehicles and Optimus robots. High-power chips hardened for the radiation and thermal environment of space. Whether Tesla and SpaceX can actually master advanced semiconductor manufacturing at this scale remains one of the biggest open questions in the technology industry. Building cars and rockets is extremely hard. Building leading-edge fabs is a different level of difficulty. Can Tesla and SpaceX actually afford this? Tesla ended recent quarters with more than $40 billion in cash and investments. SpaceX completed a massive IPO in 2026. The $16.8 billion first phase is already larger than Tesla's entire annual net income in some recent years. The business case rests on one core idea. If the companies cannot secure enough specialized chips, their entire AI, robotics, and space data center roadmaps slow down or stall. By controlling the supply, they reduce geopolitical risk, potential price spikes, and allocation battles with other AI customers. The risk is equally clear. Semiconductor fabs are capital-intensive, slow to ramp, and historically prone to delays and cost overruns. If demand for Optimus or orbital compute grows slower than projected, Terafab becomes a very expensive asset sitting partially idle. The profitability of the project will depend almost entirely on whether Tesla and SpaceX can generate the massive internal demand they currently forecast. The global leaders in advanced chip manufacturing remain TSMC, Samsung, and Intel. TSMC still dominates the most advanced nodes. Samsung and Intel are racing to close the gap. Terafab is not trying to become a general-purpose foundry selling to the entire industry. It is designed primarily as a captive facility for Tesla and SpaceX needs. That is both a strength and a limitation. A captive fab can optimize for specific chip designs. It does not benefit from the enormous external volume that keeps TSMC's utilization high. Other companies, including traditional automakers and AI labs, are also expanding domestic chip capacity with the help of the CHIPS Act. Terafab's competitive advantage, if it succeeds, would be speed of iteration and guaranteed supply for Musk's companies rather than pure process leadership against TSMC. The race is not about who builds the first advanced fab in the US. It is about who can reliably produce the right chips at the right volume and cost when the demand actually arrives. The risks are substantial. Execution risk. Neither Tesla nor SpaceX has ever operated a leading-edge semiconductor fab. Hiring experienced talent and transferring process knowledge from Intel will be critical. Cost risk. The jump from $16.8 billion Phase 1 to a potential $119 billion total is enormous. Historical semiconductor projects frequently exceed budgets. Timeline risk. Advanced fabs typically take years to reach high-volume manufacturing. Musk's public comments have been characteristically aggressive. Demand risk. The entire economic justification rests on extremely high future volumes of Optimus robots and space-based compute. Those markets are still largely unproven at the scale required. Environmental and local risk. Rural Texas communities have already raised concerns about water use, power generation, and the impact of a project this size. Power is another major issue. Some reports indicate the facility is planned to rely heavily on on-site generation rather than the grid, a significant engineering and permitting challenge of its own. None of these risks mean the project will fail. They do mean success is far from guaranteed. So what is real today? Tesla and SpaceX have committed serious capital. Land has been secured. A research fab is under construction. Intel is involved. The scale ambitions are public and extreme. What remains unproven is everything that actually matters for the long term. Can they produce advanced chips at competitive yields? Can they reach the volume targets on a realistic timeline? Can the economics work if demand ramps more slowly than hoped? The largest building on Earth is still mostly a plan and a first-phase commitment. The chips that are supposed to power 1 trillion watts of AI compute do not yet exist in volume from this facility. That is the honest state of play. Watch these milestones closely. Progress in first wafer starts at the Giga Texas Research Fab. Groundbreaking and early construction at the Grimes County site. Any updated capital expenditure guidance from Tesla or SpaceX? Hiring announcements and key executive appointments. First public statements on process yields or pilot production. Clarity on how the $16.8 billion is split between the two companies. Actual power generation plans and environmental permits. Any revision to the long-term 1 terawatt or wafer start targets. Each of these will tell us whether Terafab is moving from vision toward industrial reality or whether the numbers remain aspirational. Elon Musk's Terafab is one of the most ambitious industrial projects announced in the United States in decades. It is driven by a genuine fear of chip shortages that could constrain Tesla's robotics and autonomy plans and SpaceX's space-based AI ambitions. The $16.8 billion first phase is real. The 100 million square foot vision is real as a stated goal. The $119 billion upper figure remains a possibility listed in filings, not a locked commitment. Whether this becomes the most valuable building on Earth or one of the most expensive overbuilds in technology history will depend on execution over the next several years. The future rarely arrives all at once. It arrives one breakthrough and one very large foundation at a time. And for Tesla and SpaceX, the next foundation is already being poured in Texas. If you enjoy deep, fact-based analysis on Tesla, SpaceX, AI, semiconductors, and the future of technology, subscribe to EV Insider. Now I want to hear from you. Do you believe Terafab is a necessary response to a real chip shortage, or is the scale still more ambition than evidence? Drop your thoughts in the comments. I'll see you in the next one.